Large language models or LLMs is a form of generative AI that can generate human-like text. Not only can it be used to create chatbots, but also for summarizing text, converting instruction to content like code, generating essay on any topic, and extracting specific information from the passage. In this video, we're going to learn about the general LLM architecture, its fine-tuning and quantization techniques. Hey there! Welcome to Learn OpenCV. The heart of LLMs is the transformer architecture. Its strength lies in its ability to learn and focus on context and relevance of all the words in the sentences. The LLM architecture mainly consists of an encoder and a decoder. But the first step is to tokenize the input. Tokenization maps each word to a number from a dictionary of words and, if necessary, breaks down a single word into multiple ones. Remember, once you have chosen a tokenizer for training, you must use the same tokenizer for the generation task. The second step is to pass these tokens to the embedding layer. This is a trainable layer where each token in the vocabulary is assigned a high-dimensional vector. This way, the model mathematically tries to understand the language. The next step is to encode the position of each word in the input sequence. And then, both the embeddings are summed and passed to the self-attention layer. The self-attention layer learns the relationship between one word and the rest of the input text by assigning attention weights for each of its connections. The intuition is that each head will learn a different aspect of the language. One head might focus on the sentiment, while the other might focus on the relationship between the named entities. Check out this blog post to know the maths behind attention mechanism in a transformer neural network. At this point, our LLM is pre-trained on raw, unstructured textual data and can be fine-tuned to a specific task. One such type of fine-tuning is instruction fine-tuning, where we tailor the LLM to perform a specific task based on an explicit instruction. For example, translate this sentence or summarize this text. If this interests you, check out a blog post on fine-tuning T5 models. Another type of fine-tuning is multitask fine-tuning, which enables your LLM to work on any task, be it sentiment analysis, question answering, or text completion. And then we have parameter efficient fine-tuning or PEFT. Both the previous methods update all the model weights during training, which would take up a lot of resources. But PEFT only focuses on a small subset. It fine-tunes only a few specific layers or freezes the model completely and adds new components on it to train. Comment on this video if you'd like a separate video on fine-tuning LLMs using PEFT, and to know how to evaluate LLMs, check out this blog post. The largest LLMs can take up to hundreds of gigabytes of data, not including the memory needed during training. Using PEFT, only 15 to 20% of the model will be updated, which leads us to model quantization. Quantization reduces the model's precision in favor of model size and efficiency. It handles this by changing the model's FP32 precision to FP16 or even int 8. This way, the model loses a bit of its accuracy but gains inference speed. So that's all about LLMs. If you like this video, check out Mastering BERT and Fine-Tuning BERT NLP model. Do comment on what you would like to see next and don't forget to subscribe. Thanks for watching. Until next time.